Hello again, class. This is the lesson for Chapter 8.8b, which is on the surface area of prisms and cylinders. The surface area refers to the sum of the areas of all of its faces. Now, you have to remember that the word SUM means that you have to add up all the areas of all the faces. We're going to find the area of each particular face and then add them up. Now, the book advocates using a net like you see drawn over here on the right with the 1, 2, 3, and then the green 1 and 2. I'll admit I've got a hard time drawing a net and then figuring it out. I'm a little better at visualizing it by the face that I see. So I don't necessarily do it all by net. But if that works for you, by all means, redraw the net, fill in all the little measurements and work it through that way. For me, I have a tendency to look at the various faces. For example, when I look, I see this particular face right here. And that particular face is a rectangle. It is a 4 by 9 rectangle. I will calculate the area using my formula. Area of that particular rectangle is 36 centimeters squared. Once I'm done with that rectangle, I look at the other rectangles, and there's one back here. That particular rectangle is going to be a 12 by 4. Then I will use the formula to calculate the area of that particular rectangle, 48 square centimeters. Then I will look at this front rectangle right here. I didn't draw that very well, but hope you get the drift. That one is a 15 by 4. So I'm going to calculate the area there. And that particular area is 60 centimeters squared. Well, I'm not done yet. And here I'm going to have to bring up a different color. I'll bring up purple. Hopefully it'll show up. You have to understand or have to see that you are working with a triangle back there. Now, because this is a scalene triangle of 15, 12, and 9, again, it's based on the 3, 4, 5 triangle, you're going to have 3 different rectangles. But now we have to switch over to the formula for a triangle. 1/2 the base times the height. Remember, we have to look for this right angle. So the base here is going to be 9, and the height is going to be 12. I would take 1/2 of 12, which is 6, and 6 times 9 gives me 54 centimeters squared. Now at this point, I'm not done yet. Now I have to add all of those up. Now remember, you're going to need 2 of these because you have 2 bases. You have one up here on the top, and then you're going to have one on the bottom. So when I do the total, I'm going to add these all up. 36, 48, 60, 54, and remember you need 2 of those bases because we have a prism, so I'm going to add that in twice, and I should get a 252 centimeters squared. Now, for a cylinder, you have to understand that you have 2 circles, and then we have that kind of soup label, and that one is going to be what we call the curved surface. That's why you have a curved surface on your flashcards. The base length is really the circumference of the circle, which is why we're using 2 pi r or 2 pi d depending upon the circle they give us. So I'm going to first work with the area of the circle. Remember that your area for circle has to have radius. Oops. More than likely they will tell you to use 3.14 for pi. If they don't, again, remember, you need to use the pi key. My diameter here is 10 inches. I know that looks like 101 something or other, but it's really 10 inches. So I'm going to take it by 5, and then by 5, since I have to have the radius. Therefore, the area of one of the circles is 78.5 inches squared. Now, when I'm doing the total, yes, I'm going to add that in twice. Now, my curved surface, the area there is going to be pi. They have given me diameter, so there's my circumference, and then the height of the whole cylinder. Again, I'll use 3.14. They're giving me 10, and then they tell me the height is 14. So my area here is going to be 439.6 inches squared. Now I have to do a total. I'm going to take the 78.5 twice. There are two circles. Then add the 439.6. Altogether, you are going to get 596.6 inches squared. Okay. Here's another cylinder. Your answer is right here. You hit pause, work it through, and see if you can get the right answer. Okay, now your target was to get 138.2 meters squared. Here's how you work the problem. If you need to, hit pause again, look at what you did, look at what I did, fix it up if you have to, or pat yourself on the back because you got it right. Example D is a rectangular prism. Now, what some people do, and this is what I do, I use the idea of a top and bottom piece being the same in a rectangular prism. Kind of like if I figure, I kind of think of a Kleenex box. The bottom that it sits on and the top that you pull the Kleenex out of are going to be the same size, and those are going to be 16 by 5s. Then I look at my front and my back piece, the piece that I'm actually looking at. I suppose if you want to think about it, you could think of the front piece as kind of being right here. This would be like the front of the Kleenex box. But then you are going to have a back side as well, and that's going to be that same as that front side, and that's going to be back here. So that's going to be your 16 by 4. Whoops, didn't mean to do that, sorry. And then you've got those right sides and left sides. You've got the little pieces here and here, and those, whoa, that did not work out well at all. Trying to go too fast. That's going to be 5 by 4. Now, I have a tendency to work this way as well. Now, again, I've given you your target. Your target should be 328. Hit pause at this point and see if you can work it out and get it to work, and then I'll show you how to work through the problem. All right, class, hopefully you got the 328 when you calculated it. You should have gotten 80 feet for the top and the bottom, feet squared. Should have gotten 64 feet squared for the front piece and the back piece. The little right-hand sides and left-hand sides should have been 20. Now, sometimes what happens is students only end up with like 160 something for this problem because they forget that you have both a top and a bottom, so 80 has to be added in there twice, a front and a back, 64 has to go in twice, and then the right and the left, so the 20s have to go in there twice. It's usually a good idea to just go ahead and put them in there as 80, 80, 64, 64, 20, 20. I don't have a real big problem if you can do it mentally to put in the 160, the 40. I don't know, some of you can probably do 64 plus 64 okay to get 128. I don't have a problem with that, but please do write something down. Don't just give me the calculations for the area and then a 328 over on the side. I need to see how you get that 328. These problems do take a little bit of time, but they are all based on the formulas that you already have. If you struggle to figure out which side is which, I would suggest you try drawing a net, if that helps you. As I said, that's not something that necessarily works for me. Today, that concludes the lesson. So, if you would please respond with dodecagon. Catch you next time.